Okay, they only give me 5 minutes to explain this in this video, so I'm going to be quick about it. I'm assuming you're in a non-calculus based course because you didn't have any variable t on the v and the x, because if you took the derivative of the v and the x, then that would be 0. You probably don't even know what that means if you're in non-calculus. Anyways, you got this question here. We got a time, we got a velocity x and y initial in both components x and y direction, which means we're in two-dimensional kinematics, which means we have to use the two-dimensional equations and formulas. So what's really important for you to understand is that reading the question can often confuse you. You really just need to look at the very end. You see what is the acceleration, then look at what you're given as far as the numbers are or the components are. That's all you really need to know. Reading it can just make it more difficult because then your brain starts working, and most people's brains do not work properly when it comes to physics. Naturally, you have to learn whatever you think is correct. The opposite's usually correct in physics. So, but important on an exam, the first thing you always do on an exam to guarantee that you get 50% credit is you write out the formula, components, unknown components, like I did here. Write out the related material. That will give you 50% credit. Then you wing the rest of it, you'll get 25% credit. With a curve, you'll end up with a B or an A. You could literally go into these tests knowing how to do nothing but write the formula and pass with a B or an A. So first you write this stuff down. I listed everything that we got, T initial. Now we're looking at the acceleration. They wanted the direction, which means they want the angle, which means we need two components to find the angle, because if you remember back in trigonometry, the tangent inverse or arctangent of the y component divided by the x component will give you the angle or the direction. So we need two components. So I'm assuming that this is a non-calculus. We're just going to use the average acceleration formula here, which is the top one. Vx here is v initial, v naught x plus axt. So I'm going to use that. I'm going to use that for the x component and then the y component separately. There's two components, so we do them separately. Then we have a new vector. So I'm at 2 minutes already. So I've got the v, I got the v final, I got the time. You can see here's a plot of the velocity vectors here. It starts here, it ends here, it just goes straight down. As you can see, it goes straight down because we start and in the y direction at 0.12, then zero movement in the 2.3, 2.3 for x. There's zero movement in the x direction. There's only movement in the y direction going downward. And so you wouldn't say the acceleration is negative because of the graph. That's not how you say that. You say the acceleration is going at 270 degrees. You wouldn't say it's negative, okay? You could, that would denote it, and you would use that in equations, because the acceleration multiplied by the 270 degrees operated on trig would output a negative sign, but that you wouldn't say negative. So anyway, so we use that average formula here. We just do the x components, 2.2 minus 2.30. We use the y components, we get negative this. So there's your negative, right? That's the direction that you'd use in formulas. That's not how you would state the final answer, though. So now I've got the a and x components. That gives me a new vector. I take the magnitude of that vector. That gives me my acceleration. And then I do the arctangent of the y component of the acceleration divided by the x component, which is undefined, which tells me it's 270 degrees. Well, you can read some of this stuff if you want, but it's 270 degrees. Pause it, read it. I got to go quick because I only got a minute left. So then now I need to make sure that my answer is finalized in the appropriate significant figures. And that means, since if you go back up here, we have 0.12, we have 0.3. So the smallest one is what we use, and so we wouldn't use 2 sig figs. We use 1 sig fig after the decimal. So right here I got 5.45. It should be 5.5 because we only want to use one significant figure, because the answer is infinite. 0.054 bar goes on 5454 forever. So I round that up. I want my sig figs to be 1. And then I've got my angle, theta, 270 degrees. So the final answer is the acceleration is 5.5 times 10 to the negative 2 meters per second squared when theta is equal to 270 degrees. And that would be the acceleration average, assuming that you're in a non-calculus-based course. If you're in a calculus-based course, you're talking derivatives and for instantaneous acceleration and velocity and so forth. So that's all the time I got. I'll be here all week. Have a great semester.